All right, welcome to this little mini chapter. Yeah, we're jumping straight into this. Now there's 8 slides, so we're going to get through those first 8 slides, but I will tell you that I'm going to jump around a little bit because some of those problems I'm just going to consider optional ones where I'm going to do them in class just to give you that type of explanation. But otherwise, there's no notes. This is just straight up algebraic examples. So solve for x using what's called a sign analysis chart. So sorry, I've said so a lot of times so far. X squared minus x minus 6 being greater than 0. So what we're looking to see is when is this function positive? The way in which we do that is we factor this so that we can get what are called critical numbers or critical values. So if I factor this, this is just type 1 simple factoring. I get x minus 3, x plus 2. And then what you do is find the 0 for each term. So here I get x equals 3. Here I get x equals negative 2. Then we go to what's called a sign analysis chart. In a sign analysis chart, I'm trying to evaluate what value the overall function would have based off of each factor and the critical values. So I'm going to list my critical values least to greatest, negative 2, positive 3. I leave a little bit of space to the left and a little bit of space to the right. Personally, the way that I like to organize this is by making these columns. And then because there are 2 factors, I'm going to make 2 rows. You put each of the factors in that row, so x minus 3 and x plus 2. Then at x plus 2, at negative 2, I would get 0. And at 3 for x minus 3, I would get 0. So what we're trying to do is fill out whether or not we would have things that are positive or negative. That's why it's sign analysis. We're just concerned with the sign, not the actual numeric value. So if you think about x minus 3 is a graph that looks like this. So here, there's my 3. That's when the function is equal to 0. Everywhere before that, this function is negative. Everywhere after that, this function is positive because now it's above the x-axis. So this is going to go negative, negative, negative. It's going to hit at 0 and then turn positive. X plus 2, again, I have some linear increasing function. Here at negative 2 is where I have my 0. The function is equal to 0 right here. Everywhere before that, I'm negative. Everywhere after that, I'm positive. So if you look at what's happening to the 2 factors, the 2 factors are getting multiplied. So what we think about here is if I multiply a negative by a negative, I'm going to get a positive. A negative times a positive will give me a negative, and a positive times a positive will give me a positive. Back in the original problem, we said that we were looking for positives. So right here, I have positives. Right here, I have positives. Now, I'm not saying that negative 2 is positive. I'm saying that there's an interval going up until negative 2. So when I'm solving for x now, what I'm going to talk about is the entire interval that's infinitely to the left. Since there are no other critical values, these signs wouldn't be changing to the left of negative 2. It would always be positive. So all the way to negative infinity, this graph would be positive up until I got to negative 2. At negative 2, I would have a negative times 0, which is 0, and I only want things that are greater than 0. So negative 2 is not included. I put a parentheses. In union with, at 3 I get 0, and I don't want 0. I want just positives. So parentheses 3 on to positive infinity. So this is a sign analysis chart. This is the only thing that I'm going to be talking about today, but I'm going to be making larger charts, have some undefineds in them, and talk about how we get those critical numbers. So the second and third slide, I'm just going to skip there. That's just some more factoring. It's definitely stuff that you should go back and see because we sort of do some of those differently. But otherwise, I'm just going to only cover some of them for the notes. So I am on the fourth slide, solve for x using a sign analysis chart. First thing I like to do is pay attention to what am I looking for. In this case, I'm looking for negative or 0. So I have negative 3x cubed minus 2x squared plus 19x plus 6, minus 6, sorry. Looking at this, it is not factorable using any of my types of factoring, but I need to factor it or do something with it so that I can get the critical values. So what I have to do is the rational zeros test, P's and Q's, your favorite thing. So plus or minus 6, 3, 2, and 1, all over 1 and 3. Remember, your P's are your factors of 6, your Q's are your factors of 3. So, if you were reducing this, you have 6, 3, 2, 1. And some of these are going to already duplicate. So that was all of these over 1. 6 over 3 gives me 2. 3 over 3 gives me 1. So I have 2/3 and 1/3. Then I use my graphing calculator to figure out which one of these is the correct one to synthetically divide by. -2, actually +2 is going to work. So if I synthetically divide by that, I get -3, -2, +19, -6. I bring that down and then I start multiplying. Remember that algorithm for synthetic division. So what I have left here is -3x squared minus 8x plus 3 equals 0. One of my critical values is already x equals 2. It's one of the ones I need to remember. So I need to factor this. I would recommend factoring out the -1. So I get 3x squared plus 8x minus 3 equals 0, and then divide by that negative. At this point, this is type 2 factoring. The lead term, since it's multiplying to 3x squared, must be 3x and x. The last terms, so you're looking for numbers that multiply to -3, and one of them is going to get multiplied by 3 to give us a sum between the two of a +8. So numbers that multiply to -3 would just be 1 and 3, and the negative could be on either one. In this case, I'll put the 3 here, the -1 here. And if you double check, 3 times 3 gives me 9, minus 1 gives me 8. And -1 times 3 gives me -3. This is the only way that this can be set up. My zeros here then are -3 and +1/3. So I've got 3 critical values, 2, -3, 1/3. When I set up my sign analysis table, I'll need a relatively big table because I have 3 different factors. I have the factor that comes from 2, which would be x minus 2. I have the factor here, 3x minus 1. And I have the factor here, x plus 3. So I've listed my critical values, -3, +1/3, and 2. Make all my sort of towers, towers, and then put in my zeros. So 0 here, 0 here, 0 here. Because -3 zeros out that term, 1/3 zeros out this term, 2 zeros out this term. All of these functions are linear, and they are all increasing functions. Here's a slope of 1, here's a slope of 3, here's a slope of 1. A linear function that is increasing hits its 0 and switches from negative to positive. So I'll have negatives to positive, negatives to positives, and negative to positive. If I multiply these all together, a negative times a negative times a negative gives me a negative. A negative times positive gives me a positive. A negative, positive, positive gives me a negative. And 3 positives gives me a positive. In this problem, we said that we were looking for negatives, but there is a secret issue with this problem. And it's something that I did throughout here. I didn't do it wrong, and I did it very intentionally. So, because it's a mistake that comes up in 1 or 2 problems, right here, what we did is we factored a negative out of this, then divided by a negative. And you're looking at this and you're like, yeah, cool. What does that matter? Well, originally, this problem is actually an inequality, not really an equation. So when I factor a negative out of an inequality and divide by that, you have to remember that that switches things. So instead of this actually looking for things that are less than or equal to 0, because I divided by a negative, I want things that are greater than or equal to 0. So I'm really looking for positives or 0. Now you could do this in different ways. If I left that negative in here, I wouldn't have to worry about that. Or if you redistributed this negative to one of the terms, and it didn't matter which one, let's say I called this negative x minus 3, I distributed the negative into it, you wouldn't have to worry about that. But because I pulled that negative out of an inequality and then divided by it, I have to flip that sign. So based off of my work, I am looking for positives. That would give me this interval and this interval. So if I'm listing my interval, I'm going from -3, and this actually includes 0. So that will be a bracket. A bracket because in this column, I would get 0, and 0 is included. So -3 to 1/3 in union with 2 to infinity. Infinity always has a parentheses around it. So this is a really cool question because of that whole dividing by a negative thing, and you can deal with it in different ways. All right, moving to a different one that has a different sort of cool thing about it. So I have x squared minus 3x minus 10 over x minus 1, and I'm looking for things that are positive and not including 0. If I factor this numerator, I get x minus 5, x plus 2, which means I have 3 critical values: 5, -2, x equals 5, x equals -2, and x equals 1. So I'll make my sign analysis table. I organize least to greatest, so -2, +1, +5. Columns, rows. 3 rows because I have 3 factors here. I have x minus 5, I have x plus 2, and I have x minus 1. X plus 2 gets zeroed out by -2. X minus 5 gets zeroed out by +5. X minus 1, and this is why this problem is different. X minus 1 does get zeroed out by 1, but it does not make the entire function equal to 0. If I were to put 1 into this function, I get 0 in the denominator, which is undefined. So we put u here. Now, this only plays a role and only makes a difference in certain questions. Because if I'm getting undefined here, I could never have a bracket around 1. In this case, I wouldn't be using brackets anyways because it doesn't include 0. All right, all of these are positive increasing functions, linear increasing functions. So negatives to positives. You'll notice that a lot of these are going to go in the format of going from negative to positive after hitting that 0, but not all of them will. So don't just, ignore it and think that they're all like that. 3 negatives is going to give me a negative. 2 negatives and a positive will give me a positive. 2 positives and a negative will give me a negative. And 3 positives will give me a positive. Same thing as what I just said. These signs will not always just alternate. A lot of times they do, but not always. For my final answer, I'm looking for positives. So here I have positive, here I have positive. So from -2 to +1, in parentheses because 0 is not included, in union with 5 to infinity. What I am listing when I'm listing these is the x values across the domain where this would be positive. All right, moving along, just 2 more mandatory examples. Solve for x using sign analysis chart. So in this case, it's just the factoring that I'm going to be doing that's a little bit different. When I'm looking at this, there are 2 terms in this inequality. And what I want to do is not multiply it all out, but instead factor out. So when I look at them, I have 2 and 3. Well, there's nothing I could take out of 2 and 3. There's x and x squared. So from that, I can take out a single x. And I have x minus 3 squared and x minus 3. From that, I can take out an x minus 3, just one of them, because you have to take out from both. Then in this bracket, I'm just going to use this as like a giant parentheses. What I'm going to put is what I would be left over with from each term if I took this out. So if I take x out of 2x, I'm left with 2. If I take x minus 3 out of x minus 3 squared, I'd be left with an x minus 3. Bring down this minus. If I take x out of 3x squared, I'm left with 3x. And if I take x minus 3 out of x minus 3, they're all just gone. Now I need to simplify what's inside here, so I'll distribute this 2. I get 2x minus 6 minus 3x, which gives me negative x minus 6. So I have 3 critical values here. X equals 0, x equals 3, and x equals negative 6. In this problem, I'm looking for negatives. So I make my sign analysis table. I'm going from negative 6 to 0 to 3. So I've got 3 columns and 3 rows. Each factor, x, x minus 3, negative x minus 6. I put in my zeros, so 0 zeros out x, 3 zeros out x minus 3, negative 6 zeros out negative x minus 6. These first 2 are linear increasing functions, which means they go from negative to positive. This last one is linear decreasing because the slope here is negative. So you have something that looks like this. Here's my linear decreasing function. A linear decreasing function starts off positive, hits my x-axis, and then becomes negative. So it goes the opposite, positive to negative. Negative, negative, positive gives me a positive. 3 negatives gives me a negative. Positive and 2 negatives gives me a positive. And 2 positives and a negative gives me a negative. My final answer, I'm looking for things that are negative and not including 0. So negative 6 to 0 and 3 to infinity. The exact way that I just said that is how I will write it. Negative 6 to 0 in union with 3 to infinity. No brackets because neither of those would be included. All right, that's actually the last one that I'm going to do as part of these mandatory notes. I do recommend, like, if that seems like you're like, I don't know, that's sort of confusing, go back and now watch the optional video. It's just more examples of this, but like those more examples can't hurt. Bring in questions. There should be some questions because, you know, this may not be something super familiar for you, and especially that one that had that dividing by a negative, ask on that one because there's tons of different ways that you can sort of deal with that. I mean, really, I can think of 2, but we could say that there's tons. Because your work could look different deciding or depending upon what you do with that negative. But your answer can still come out correct and everything can still be right. All right, thanks. Good luck.